In this video, we're going to look at an example so we can see why percents. Why do we use percents and why are they useful? So let's read through this problem and highlight important information. Sylvia has taken 3 tests in her math class this semester. The table below shows the number of points she earned out of the total number of possible points. And the first question asks, based on the information in the first 2 rows, so points earned, total points possible, and these are the 3 tests. On which test do you think Sylvia earned her best score? So that's the question. Which test do you think was her worst score? And explain. So I'm not going to answer this question, you are. So take a minute and just look at these values and don't worry about being right or wrong. Just make sense of this problem as best you can and write down which test is the best, which test is the worst, and why you think that's so. So go ahead and pause and take a moment to answer that question and then restart the video. Now we're going to complete the missing rows in the table. So we have points earned and total possible points, but we're going to fill in a few more columns. We're going to look at the ratio of points earned to total points possible. So we're going to find a ratio that's a multiplicative comparison of points earned to points possible. Then we're going to write an equivalent ratio out of 100, and then we're going to write the equivalent percent. So here, the ratio of points earned to total points possible is 18 out of 25. Okay, let's go down in columns. So now let's write an equivalent ratio out of 100. Well, that means I want to, and we'll learn how to do this on the calculator for harder ones, but I want to write this out of 100. So to find the multiplying factor, you can think of dividing 100 by 25, or what do I multiply 25 by to get 100? And that would be 4. So multiply the top and the bottom by 4. Okay, that gives us 100. 8 times 4 is 40, and 32, which is 72. So an equivalent fraction or ratio of the points that she earned on test 1 is 72 out of 100. Now percent, as described in the media lesson packet, means per 100. So the equivalent percent, this is 72 per 100, so we write 72%. So all 3 of these forms are equivalent. They all represent the same ratio, but they're writing it in a different way. This is based on the original amount of points earned to points possible. This writes that ratio out of 100. And percent notation, this symbol right here is what we use for percent, means per 100. So 72 over 100, 72 out of 100 is equivalent to 72%. Let's do the next one. 16 out of 20 is our ratio. If we want to write that as an equivalent ratio out of 100, we want to think, what do we multiply 20 by to get 100? Well, that would be 5. And 16 times 5 is 80. So this test, she earned 80%. And finally, here we have 39 points out of 50 possible points. Now we want to write that over 100. So to get from 50 to 100, I would multiply by 2. And 39 times 2 is 78. So on test 3, she earned 78%. Let's look at the next question. Okay, so here's all of that information in a table for us. And now we were asked, based on the information in the last 2 rows, on which test do you think Sylvia earned her best score? Which test do you think was her worst score? Is this different from your original analysis in Part A? Explain. Okay, so I don't know what your original analysis was, so you're going to fill that in yourself. Okay? But if we think purely in terms of not how many she got wrong or correct, I mean, here she got the most correct, but there were more questions. Here she got 4 wrong, and here she got, let's see, 7 wrong. If we don't consider those comparisons, but just the multiplicative comparison, looking at the percents or the ratios out of 100 are a way that we can compare these values with a common denominator. Okay, so I would say that her best score was 80%. Best score is 80% if we're looking at them relative to 100, and that was test 2. And her worst score was 72%, which was test 1. And our final question is, why do you think it is useful to use percents to compare ratios? Explain. Well, this example shows us why it's useful. When we're looking at fractions with or ratios with different denominators, it's hard to get a feel for which ratio is closest to 100% in this case. So it's hard to compare, so we can find a common denominator. We could have found any common denominator, but the idea behind percents is when we start using a common unit like a percent many times, they start to gain meaning for us. So if your tax rate is 9%, you probably have a feel for what that is when you go to the store. If they said they were going to raise it to 20%, you would probably be horrified. Okay? So it's useful to use percent to compare ratios because they use a common denominator of 100, so it's easier to compare ratios. And using 100% frequently gives the number meaning. So we develop meaning. So just like you may have a sense of what 10 feet is, I could make a new measurement that maybe is the length of a book and say, oh, this is 10 books long. Well, you don't really know what a book length is. Is it a small book, a big book? Okay, so this gives us a common unit of measurement so we can compare values.